Welcome back to my Pixinsight tutorial for absolute beginners series. Now in the last video we talked about removing the green cast from our image, and we had used a couple previous videos back. We used ABE, the automatic background extraction, and then we used the dynamic background extraction. In this video we're going to look at color calibration. Today's video we're going to I will attempt to show you a simple way to make RG and B equal. In other words, even. Not too much red, not too much green, not too much blue. And this image looks really green. What can we do? Well, the first thing, I'll bring out the processes. There's background neutralization, color calibration. Those are the two things we'll be using. The first thing I want to do is to zoom in on the image and find a nice background area that has no stars. In this case, it's going to be tough because there's a lot of stars. Stay away from your target. Here's a little spot right here. So go up to the top and click on the new preview mode, or Alt-N. Let's try Alt-N. Alt-N. And you can see my cursor changed. And I got a nice little spot right about here where there's not really any stars. That's pretty good. Remember, just find a nice piece. It doesn't, and Pixinsight does not need a lot of area, just a little area, but it has to be background for all intents and purposes. It cannot be on the target. It has to be way in the background to neutralize the background. So we found a little spot. Let's open background neutralization. Bring that module over here so we can see it. And I'm just going to, zoom out a little bit. And under the reference image, our preview 1 is the reference. So there's a little window here. Click on it, drop down menu, preview 1, and OK. Now before I drag the triangle onto it and apply it, after it's done you probably won't see any difference at all to your eyes, but trust me, something has happened over the entire image. It's sometimes very, very subtle and you can barely see it. So let's drag and drop it. We kind of have to have faith that it's doing its job. So it's done. I mean, even if I go undo background like this, redo, wow, there's just barely any change. It might went a bit from light green to a lighter blue, but we're shooting for is gray. So redo background. Oh yeah, wow, you can't even tell. Okay, so that's done. Now we want to keep the background preview available. Suffice to say that you did it and it's been applied. Let's go to color calibration. A little larger window, a few more options. Now we're going to need another preview. This one was for the background, which is the darker part of our frame. Now we need one for the white reference. So Alt-N, our icon changes. I'm going to select the core of the galaxy. Some people select the entire galaxy. You can. Why not? Let's try it. Without getting the background in there, let's grab a lot of that white. There you go. So this will be our white reference. This already has been our background. So reference image in the white, click on the little window, drop down menu, preview number 2, because it says 2 here. I don't want to sound like the kindergarten class, but some people have said you're going too fast. 2, and background reference is the little window, and it of course is preview number 1, which was earlier our background. So now this process will color calibrate. We'll choose the white, choose the dark, and average out everything so we have a neutral colored image, not too green, not too red, not too blue. When you're choosing large sections as a preview, there's some stars included, so sometimes I select structure detection. Don't change anything. Grab your triangle, drag it on there, and let's see if it changes. Hopefully I didn't forget anything. No, it looks good. Let's see if it changes the color. All right, just going to minimize this for a second. And you notice the picture went pitch black, so it made some adjustments. The very first thing I noticed right away is the white just got a lot whiter from that yucky green, and even that little galaxy down here is kind of a nice bluish white. So let's open up our screen transfer function. Let's bring this back up to speed because obviously it's been darkened. So you just have to hit this, it'll normalize it. And remember what I mentioned about the auto stretch? Pixinsight does such a good job. If the data is good, if it's really, really, really good, if you had hundreds of frames, And all the stacking went well, the integration went well, the registration went well, the calibrating darks and flats, some people use bias and their lights, that all went well. The noise was subdued to a degree. Pixinsight will do a really good job at stretching this. It will never go past, it will never clip or go beyond what's usable. What you will see is what's usable. Let's click it. So there it is. That is incredible. There's no way that if I went into Pixinsight, not Pixinsight, but if I use my Photoshop CS6 and attempt to align these colors, and I can do it, it's not hard, manually, right, to color calibrate the RGB. So this galaxy is now a nice whitish blue, which is what we intended, and not this other heavy green cast that we had. And sometimes it's just caused by the light pollution. Remember, we used dynamic background extraction and we removed a lot of the pollution, a lot of the gradients, some vignette, some hazing. It wasn't a very clear night. But this, now we're talking about color calibration and not removing any haze or any gradient. And it's very nicely white. And if we, more than likely, and we can test this, I'm not afraid, I'm not hiding anything. If I go to the histogram, okay, and we choose M31, which I think is integration 1, not right here, okay, and we saw, if you click on the check mark here, track view, want to track the view, click anywhere in between here, just click, and scroll your mouse. For all intents and purposes, anything in the white means that RGB has been aligned really, really well, and I like it right down to the green being at the very center. Blue is a little bit to the left, so there's a little less blue and a little bit more red. If you wanted to get fussy, and you could just click the blue channel. Of course, you'd have to zoom back out because you won't see where the arrow is in the center. You could keep an eye up here though. See the left blue here? You could grab this arrow here. It's either to the right or to the left. To bring this blue back into the white to make it completely neutral. Let me just go let me see if it's to the right. So this is wrong. I'm going too far to the left. I'm going to stop right here for a second. To see it, you would have to open up a real-time preview. I'm going to do it again. I'm going to force too much blue. See what's happening? If I remove to the left this, if I remove it to the left, that means I'm subtracting blue from the image. I'm leaving a lot of yellow, green, and red. The yellow is a combination of the green and the red, I believe. But if you go in the other direction, make this curve up, bring the blue back to the center until it completely disappears up here, then the image should turn black and white, right? About there. That's what the camera saw, and this is what we have in terms of just blue. Click back on RGB. All three colors are equal. You can close this preview if you want. And if you want, you could drag the triangle and just do that. Find a little tweaking. Most people don't. I don't. Actually, that just went a little bit bluer than it should be. You can undo it, redo it, and that's, well, M31 is kind of a reddish brown blue. So that's very, very good. I just did a whole bunch of other things that I wasn't going to do in this color calibration. You can close this and you can close that. But I just showed you, two extra little steps. For the color calibration that you can play around with. Remember, this is all experimental. I don't know, you may have never shot M31, but you still need to neutralize the background so it's a nice dark gray. We zoom in here, right? So, and you can see all the different, the blotchiness from the RGB camera, and then go into the white. The white is very, very nice. And again, you go back to the background, you got your RGB, and they're all there. And there's a lot of noise because no camera has no noise. All cameras have noise, no matter what the manufacturer is bragging about. So what did we do? What did we learn? Let's close this. We learned that we can neutralize the background by making a little square somewhere in the background of the image where there's no stars. And then you can apply it, and that'll neutralize just the background. That's one. Two, color calibration. We have made a second preview window, Alt-N, or go up here and click on it. Could even make a third one if I wanted on these stars. Go down here and look at them. Here's our stars. Number 2, preview 2. Here's our core. Zoom out. Number 1. So this is number 1 right down here. Preview 1. Go to preview 1. Going to stretch it a little bit. And there's our nice, beautiful noise. which we're going to deal with later. So that's color calibration. So you have a white reference, you have a background reference, and Pixinsight will take both of these and average out all the colors to a beautiful white based on the star color, which should be white. Some stars are yellow, some are different colors. But that is color calibration, and that's another one that spends some time. There's not much experimenting to do. Choose a white reference, choose a background, and structure detection if there's a bunch of stars in it. I've seen people do this in a different way. They didn't choose the preview for the background. By the way, if this is highlighted green like that, then you can go over here, way over to the red, and say delete that preview. Now, if we come back to the image for a second, now they're both white. Well, someone might say, hey Mitch, how come I can't move this box? I'm trying to move it and I can't grab it. See this little cursor, preview cursor, edit? So click on it. Either now you can move this one. And so you can move this one around. If you want to move this one, you can move that one around. Sorry, I just made it smaller and I can't even see it. So we're going to have to zoom in here. Okay, so here, this is a good example. Let's say you're stuck and you can't move this. Oh, there we go. I was able to search. But let's say you're stuck and you could no longer move this, but you can still see the blue bar. Just delete it like that. Or you can also go to preview, right click and delete, but we don't want to do that. So we'll leave the preview one. Again, select, move it around, or select, delete, or select, delete. So that takes care of color calibration and a few little tricks about working with the preview boxes, moving them around, resizing them by grabbing the corners. If you want to, again, see if I want to grab this, I'll have to go here. My cursor turns into an arrow. I can grab this and just make it tight and bring it right in the center. So all I have in the galaxy's core is just the white here. I'm excusing the outer parameter. Of course, I deleted my number 2. Don't do what I do. Don't go to Don't go to the reference target or reference image and choose 1 for white, which is black, and 2 for background, and reverse, and your image goes crazy. It happened. I mean, it has happened. I went here and I dragged down. And I had about 4 or 5 of these, and I didn't know which one was which. I got, so I had to simplify by removing a lot. There's also an image here that doesn't belong here, and it's on another window, and we're going to talk about that next. So cancel that. We're very happy with this. It's no longer green. It's got a little bit of a purple looking thing, but for all intents and purposes, this is very, very, very close to being perfectly RGB'd. Excuse me, let's close this. What do we do? What did we learn? Always save your image right away, because now it's all been cropped, ABE'd, DBE'd, background neutralized, color calibrated. Let's save it right now. Done. And of course, this little preview is no longer needed. Now, this is going to be a 2-part series within one video. We use the simplest background neutralization and the simplest color calibration, and this really does a good job. I do that right after DBE, and you notice my icons are actually in order of use, which I was teaching other of my friends that if you're going to make a workflow, then normally do all your debayering, your star alignment, your integration, then you crop the image, you remove the green cast, either or, whichever you enjoyed using, whichever you like using, whatever gives you the best result. Then some people at this point, because let's say this is 5,000 by 3,500 pixels, that's a huge image. And some people say, I'll choose M31, and I'll say, that's a little too big. I'll cut it down to about 2,700. Still a huge image to post online. So 50%. If you just enter 50 here, 50, hit enter, it adjusts them both. Now we'll go from whatever it was, just under 5,000 to 2,000 by 1,300. And why don't we do it? Watch this. I'm going to resize this. It'll end up showing smaller. I'm going to shrink that from 4,000 to 2. Okay, now re-hit this button. And then hit this one again. It's not that small. It's still very large. So we resized / resampled it. And this could print at 8.5 by 11. So this would be this could be a full page print and still be really high res. Close this file, but this time save as. And I'll put a little RS in front of that. Just put it for resampled or a little bit. So I'll know that this one is not as large as the very first one. Let's leave this here and go to the second window because we're continuing on color calibration. Now, this is not M31. It's a different image that I brought up. I had to search for it because I wanted something that was, again, we're looking for color calibration. But we're not going to use background neutralization. We're not going to use color calibration. We're going to use photo-metric-color-calibration, which is a process that came out, I think it was last year, which just added to Pixinsight as a new module. Nothing's been done but stacked and background DBE, EBE, and a bit of a crop. That's not important. So what we're going to do is we're going to find it. We're going to use a different way. So this is the process. So you would go process, all process, photometric color. I can open it up. It won't. I don't think it can open two of them. So I click on it. There it is. Now let's go through all these nice little drop-down menus. The reference is a galaxy because all galaxies emitted lights are white, regardless of how much we paint a galaxy in Photoshop or in Pixinsight. Galaxy stars are white, and we want the white to come from the galaxy. The second step is to find a server near where you live that contains all the database for all the galaxies. And I even though I live in Canada, Victoria, I think it's could be British Columbia. Usually Victoria's in British Columbia. I don't know where this is. I don't care where this is. It doesn't matter to me. But I like to use Cambridge. It works. Cambridge server seems to respond pretty quick. I mean, you can go to Russia, you can go to France, you can go to Hawaii, South Africa. Now, in the right ascension and declination of Orion, M32, there's a couple of ways to do it. If you are using Sequence Generator Pro, or a couple of other programs which insert the coordinates in the header, then the header will contain the focal length, pixel dimension, observation date, and a whole bunch of other things. Now you can try it. It says here 535 at -5. I actually tested this earlier, so I know that it is, but let's have a look first at acquire image. It says focal length was acquired, the object's RA, and the object's declination. The following metadata items have been retrieved from the active image. That's great. So go OK. And see it says 024, 023. To me, that doesn't look right. Doesn't look like that. I think that's not where M42 is, Orion. And so I just double check I will actually search the coordinates of Orion. So I'm going to type in M42. I did already. There it is. And so I'll search that. You'll have a little, here we go, M42, it's H2 region, and it's at 5. So get that information and insert it into the RA index. So go ahead and hit get 535, 523. So that is the correct parameters for the right ascension declination for this image. Now, maybe I forgot that this was actually correct. The header is supposed to contain the correct RA index, and I think it did, but I did it manually to show both ways. If you have it in the header, click acquire from image. If you don't have it in the header, go search, type in whatever, M31, M42, whatever this particular image is, go get it. It'll populate this automatically. Now the important part. The focal length, it's a C8, and if it was reduced to f6.3, it would be 1260 millimeters. If you're using a Richny-Chrétien RC6 and it's 1350 and you reduced it to f6, that'd be like 900 millimeters. You have to know this, and it has to be dead on, or this will not work. And sometimes I have the correct length. I know that and sometimes I execute it and it still fails. And it says why your parameters are not quite exact. So, but for all intents and purposes, I know that this was taken with the Astrotech 72mm ED, and it's 430 millimeter. I know that my Hypercam from Altair Astro 183 one-shot color has tiny little pixels of 2.4 microns. I know that. So I enter it in. It has to be very, very accurate based on this image. Catalogs are automatically selected, same as the limiting magnitude. It'll search that out for itself. What else? Don't touch any of these. These are all default. Some people change catalogs. Sometimes I will change the magnitude from 12, 14. I'll bring it down to just look for, this is going to plate solve this image, find out where it is, what it is, and then apply the server RGB colors of that galaxy to the entire image to make it. Sometimes I limit to magnitude 10. If for us, people that are starting, leave everything to default. Everything default. Again, minimize. We drop down here for a second. You can force plate solving. I think that's really, really important. Very important. Enable the target image to be solved to contain a valid right ascension declination and its dead center. Sometimes when I can't get this to work right, the focal length and pixels, I'll say ignore existing metadata that was acquired from the FITS header inside the image from SGP. Solving, don't ignore the data because I already got the data, so everything is okay there. And then all you have to do is, if you got this right, drag, drop it, and wait for it to happen. Okay, looks like if you see a blue bar here, you've passed the point where it says plate solving failed. So this is a really good sign to see. It's good to see that this blue, it found the image. In fact, it found some stars. 12 stars had invalid position. Some stars have problems. 13 stars were, reference was 186 stars. I like to keep this open and kind of look at it. And my image scale is 1.14 arc seconds per pixels. That's exactly perfect for my 72mm refractor and my camera, which is the Hypercam 183C. In this case, this finds each individual stars. You'll get a chart. As soon as this is done, you'll get a chart showing the stars that it chose to average out the color based on the galaxy from the server in Cambridge. So that shouldn't take too much longer. I didn't want to pause this. I actually wanted to let this run. Only takes about a minute. And look at, there's the output. Move that over a bit. Move this over a bit. Reopen up the console. So the RGB, so in red was 1.2, the green was 1.0, and the blue was pretty heavy, and the blue was 1.6. And that makes sense. I mean, the Running Man is blue, Orion is blue with some nice pink, which would make the R here 1.2, and very little green, a little bit of green, but not that much. Okay, so I'm going to minimize the photometric color calibration window, which worked very, very well. Let's move this over. These are all the stars that have been chosen here to calibrate based on the server. These are white balance functions. You can actually hover over a star, and there's stuff here. I have no idea what it means. In order for all the pixels on your camera to be white balanced, these have to be taken into consideration. First RG, then GB. So just minimize it. We'll close that in a minute because we don't really need this. What we want is the result. And here's the result. This is not stretched. You forced it to go dark again because it color calibrated the image. And for all intents and purposes, it's really well corrected. The pinks are nice. The blues are nice. The gray is nice. The Running Man's a nice blue. So let's go back down. Let's use our screen transfer function. And again, we're not looking at the quality of the image, but there it is. Let's see if I can make it bigger for you guys to see. And that's it. That is the photometric color calibration module that makes the stars really white. Now, okay, this is the result of properly calibrating all the colors. The red here, the green, which is not really, there's not a lot of green in this image, but the pixels, all the green pixels are here, but they've been averaged out, so it's not really green. There's the pink, the blue, the white, and some green. If we go over to Running Man a little bit, it's a very nice color. I like it. Yes, you can tell the noise is there, that's for sure. But so we have it here. Let's go back to manually color calibrated using our two modules of station and color calibration, which worked very, very well. And you can also use the photometric color calibration module. Make sure you enter all the information properly. If you don't know what it is, find out somehow what your telescope is, what your camera is. Make sure the right ascension declination has been chosen using the search or acquire it directly from the FITS header. Make sure that you're going to choose force plate solving. And the catalog should be automatic. Some people choose Tycho, others choose Gaia, but I wouldn't play with that. I would just say automatic catalog with automatic limiting magnitude, and you saw a very good result. Okay, that's it. Basically, we have just covered calibrating your image using those two little guys right here, background, right here. When you create yourself a little background preview, then we came back to the second one, which is using a white reference, the center of the galaxy, and the background, which was down here. That's doing it manually, and you just apply it, and it uses those two little preview windows to adjust it. On the second one, the photometric color calibration module did all the work by, as long as we said which server we want to use, and we knew how long our focal length of our telescope was, 430 millimeters, and my camera has 2.4 micron pixels. And this is the result, which is very well calibrated color-wise. Not sure if I'm missing anything or if I'm leaving anything else. Not sure how to answer that question. I think I'm going to get this question. Let's say it's a huge, wide field. There is no core of a galaxy. Maybe it's edge on. And so, well, what am I going to choose for a white reference? Good question. As of now, I haven't really hit that. I haven't done that yet, but here's what we can do. Let's say that's a problem. Let's say, well, I don't have a white core of anything because it's not that kind of an image. So here's what I would do. Maybe I'll do that one day just to test it, but I'll go back here. I would take my little selector, choose the background. Okay, now because there's no white here, this is just a star field of the Milky Way. There's no white reference except the stars. So open up your color calibration and this time go to white reference and select all of M31, all of it, and say OK. And then go to background and select number 1 because it is available. Then structure detection of all stars, drag and drop. I don't know if you can do this twice. I'm going to try it, just undo it. And that in your image should render the color natural, and looks like it did a good job. I'm actually going to keep that. It brought back a little bit of nice light yellow, which Andromeda kind of has, and my star color is nice now. Nice yellow stars, or some white ones, nice yellow ones. So hey, we learned an extra thing that, and I'll actually overwrite that file because I like the result. Okay, so I'm going to remove the preview. This is the result of aligning the R, G, and B. We've neutralized the background, so it's not too red, not too green. Color calibrated the entire image using the second process, which is right here. Sorry, I didn't know you could drag that on there. I just dragged the whole icon onto it, and it adjusted the color properly. Oh, if you drag and you drop this, you know what's going to happen. It's going to create something for you. We just learned something. I just learned something. And here we did photometry, photometric calculations based on the Harvard servers, which is right here. These stars are the representations of these stars in the background given their various colors, and when it averages them out, we can close this now. This is the color. Guys, that's pretty well it. I don't know if I forgot something, and I always do. And you saw me do a whole bunch of little things that you guys can experiment. What's the key to all this? What's even my last 6 videos? Experiment. Change values. I'm trying to use the simplicity of things to try to get things averaged out, so we have a nice little picture that we can show everyone. And I hope this is, again, it's helping. I'm trying to keep it simple. I try to break down everything I'm doing to my knowledge. I've made a lot of mistakes in the last 6 videos. I know that. I don't want to re-record them. Keep speaking as I make another one. I'll say, well, in the last video, you might have noticed that this. So hopefully I'm going to try to make note of these things and bring them up as we go along. So this concludes this part of the video. I believe this is now part 6 of 12, and we've covered everything from stacking, cropping, all the way down to getting a nice color of the galaxy or the nebula, something that has a nice RGB that we can work with. Next step is going to be, I found, to me, by far the most difficult, and that was removing noise. And there's thousands of videos on noise removal on Pixinsight. I can't do what they do. These guys are professionals. I will show you my way of noise reduction. There are 10 ways to reduce noise. There are so many modules for reducing noise. There's A, C, D, and R. There is TGV denoise. There's morphological. We're going to play with morphological transformation to denoise. There's multi-scale median transformation to remove noise. It goes on, and I'm not going to do that. I'm going to show you not so simple, but not too difficult way to deal with all this stuff here in the background, all these little noisy pixels that have been accumulated from the chip being hot. And if this is 30, 60, 90 frames, and you accumulate, you're accumulating frames, you're multiplying the noise along with the background and along with whatever that night's shot noise and floor noise, and this is a whole different subject. All the noises that are inherent in the CCD, we're going to try to minimize it. So this is it. Hope you enjoyed this particular video. This is the last one, and this one are huge steps. If you've gotten this far right now, and all that's left from now on is to get into a little bit of the deeper stuff, but you've got your image fairly well ready, you're doing really, really, really good. Hope you've enjoyed this so far, and you're taking notes, or you're downloading the video and you're playing them over and over and over again. Skip out all my talking and just get to the point of my presentations, and it'll simplify things. But I like to say what I'm doing, and as much as I can, why I'm doing it. As far as understanding the technical part of the script, I don't know, I don't care, it doesn't matter to me. If it's doing what I would like it to do so that I can show something that's reasonable picture-wise, then I'm happy. If you enjoyed it, don't forget to subscribe. Please click the bell to get updated videos as they come up in the next few weeks. And tell your friends. And again, I enjoyed this. This is a lot of fun. I think we're moving along quite well. So thank you, and see you on the next video. Bye for now.